My name is John Michael E. Reyes and I'm from Batangas State University and I'm currently a second year BSIT. And today we're gonna discuss about the Chapter 7 activities, the IP addressing, and we're here to learn about the conversion of decimal to binary and binary to decimal. And this is the first activity, the decimal to binary conversion activity. It is a pretty simple activity because it is very easy. As you can see, you're just gonna convert a decimal to binary. But let's try. At first, as you can see, these are the decimal value 74. The technique is in this is somewhat used. You'll subtract the decimal value into the position or bit position of the binary. If it is cannot be subtracted, you should put 0. Just like this. 74 cannot be subtracted by 128, so it would be 0. Then 74 can be subtracted by 64, so it would be 1, and the difference in that is 10. So 10 cannot be subtracted in 32, and 10 cannot also be subtracted by 16, but 10 can be subtracted by 8, so let's put 1 in here. Then as you can see, 10 minus 8 is 2, and 2 cannot be subtracted by 4 because it is larger than the difference. Then let's put 0. Then into 2 minus 2 is equals to 0, though let's go for 1 here and 0. And then let's check. As you can see, it is a correct position or incorrect. We already turned them into a binary. 74 is equal to 0, 1, 0, 0, 1, 0, 1, 0. Then let's try a new number, or 128, 161. I mean, then this new number is, as you can see, we can subtract 128 to 161. So let's put 1 in here, and the difference would be 33. I mean, so 64 minus 33 won't go, so let's put 0. Then 33 minus 32 will be 1, so let's put 1 in here. Then 0, 0, 0, 0, and 1 can be subtracted by 1. So let's put 1. Let's check. So you can see we're all correct again, and let's proceed to another activity. And we're here at the second activity. This activity is somewhat not an activity, but it is a game. It is called the binary game. So let's play. And let's try. So you can see there's our, then what will be equal to 5 in the binary. So it will be 4 and 1. It's 5. Then let's try to 0 it, and 2. Then sorry for that. Then 1 plus 2 is equal to 3. And it should be 16. It's 255. And it will be 64. Then this will be 4. It is somewhat very easy because I've already know what's the binary. 244 244 would be 224. I mean is 111. This game is pretty simple. As you can see, it's somewhat easy for us because it is somewhat, if you just think it, you could answer it. You could, and as you can see, it is very easy. And that's all. This game would 255 would be like this. Then the 4 is in here. That's all. As you can see, that's a very easy game. And now we're in the third activity of the IP addressing. The second one is the binary game. It is somewhat refreshing for us because it could boost your brain to convert the decimal into binary. So this one is activity is ending to determine the network address. It is somewhat just adding the host address and the subnet mask. And in adding that, let's try. The first is, as you can see, 1 plus 1 is equal to 1 because positive plus positive would be positive, then 0 plus 1, it should be 0 because negative plus positive is somewhat negative, so it would be 0. Then 1 plus 1 again would be 1, and 0 plus 1 is negative, so it would be 0. And 1 plus 1 would be positive, it is 1. Then another 1 plus 1, positive, then negative plus positive, it would be negative, and negative again, or 0 plus 1 would be 0. Then in this one, as you can see, 3 negatives, and if you just see the zeros, it would be 0 in ending, so it would be 3 zeros. Then if 1 plus 1, then it would be 1, then again 1. Then if there's a 0, 0, 0, and if there's 1, if you are to adding ones, it would be 1. Then as you can see, this one is 1, then the rest will be 0, because as you can see, in ending, if you have zeros, the sum would be zeros. Then 0 again, then 1, 1, then 0 again, all because they're in subnet mask, as you can see, there would be 0. Then in this one, this would be 128 plus 32, 128 plus 32 plus 8 plus 4. Let's try to calculate that. 128 plus 32 plus 16, 8 plus 4, it would be 172. Then this 128, 64, 32, 16 plus 8 plus 1 would be 25. No, 1, 2, 4, 8, 16. No, it's 25. 15, it's 25. Then this would be literally 128 because of already just 1. Then 64 plus 32 is 98, 96. Then let's check. As you can see, our binaries are correct, and let's try another one. Then would be 0, 0, 0, 0, 10, 0. Then other one would be 0, 0, 0, 0, 0, because of, as you can see, the binaries here is pure of zeros. Then this would be 0, 0, 0 because, as you can see, the subnet mask is already 0, so it would be all negative or somewhat 0. Then this would be 0, 0, and this would be 1, 2, 4, 8, 16, 24. This would be 24. Then 1, this would be 10. Let's check, and we are correct again. And as you can see, ending is somewhat very easy to determine the network address. And this is the fourth activity of the chapter 7. It is somewhat about the unicast, broadcast, and multicast. And as we all know, unicast is only sending in a specific location or devices, and multicast is somewhat having a group of sender but not all, and the broadcast is somewhat the all of the servers or the devices that you are sending will receive all the informations. Then this is somewhat you will choose if it where will the message will go, if it is a unicast or broadcast or multicast. Then let's start. 225.5.77.126. Then this one is like that, 77, 77. As you can see, it is a multicast, and you have successfully identified the transmission type. Then let's reset another one. Then 255 and 77 again. Why? It is already a multicast. As you can see, it is also easy. Then 192.168.100.25, 100. It is a broadcast because of the 25. Because all broadcast address have all ones in their host numbers. 126, and as you can see 126 is just a multicast address again. Then just like that, it's very easy. Then let's try to reset, start. Then 192.168.2, so you can see that it is the only one with 0.2, so it's a unicast address. And that's all for this activity. And guys, this is the fifth activity, the types of IPv4 address, the pass or block IPv4 address. It is somewhat determining if you should pass or block the IP address, because some of the IP address are in private, so you should block them or pass, and some other IP address are in public. So let's try to start. I'm not pretty good at this because the IP address is somewhat I didn't know, or I only know few. So let's start. This would be pass. Then it is so fast that I can't explain, sorry for that. Then as you can see, pass again. Then this would be pass again. Then block. Oh wait, it's already 4. Oh, why? Pass. There's too many pass to be blocked because of the 10 pass. And as you can see, it is somewhat just easy, but I can't explain it because the game is so fast, or the activity is so fast. I can explain the IP address of that. And that's all for today. Thanks. And this is the sixth activity, the public or private IPv4, just like the other one if you would pass or block it. But this time we are gonna try to separate or choose where the IP address should be, and let's answer it. Then 172.16.35, it would be in private because it is in private, as you can see in the IP address. Then 192.168, it would be definitely in private. Then 192.0, as you can see in the second point, the 0, it would be in public. Then the 64 would be I think it's in it's in public. Then the 209 would be in public also, because of this 209 it should be only in 192. Then 172 is in here again, and then let's check. As you can see, we're all correct. And as in private networks, it is somewhat in 1922 up to 192, and the public network has somewhat just like this pattern. It has zeros and other stuff. And that's all. And this is the seventh activity of the chapter 7, the IPv4 issues and solutions. Then now let's try to answer it. Drag the IPv4 and the IPv6 term to the field next to the appropriate description. So let's try it. 128-bit address /340 undecillion address. As you can see, 340 undecillion address. That would be a IPv6 or Internet Protocol version 6, because somewhat Internet Protocol version 6 is somewhat higher and more efficient than IPv4 or Internet Protocol version 4. That's why it would be in A. And this statement right here, the 340 undecillion address would be fit to IPv6 or Internet Protocol version 6. Then the 4.3 billion will be the IPv4. It is a 32-bit address. Then the 128-bit address is somewhat just like that. Then transport an IPv6 packet over IPv4 network. It's just like a tunnel, so it somewhat just like a cloud in here, then a cloud in here. The cloud in the left would be IPv6, then the cloud in the right will be IPv4, and as you can see, you can transfer them just like that. That's why they are gonna go into the process of tunneling. It is to transport an IPv6 packet over a IPv4 network. Then uses NAT64 to convert between IPv6 and IPv4. It would be translation, because as you can see, there are already the keywords in here. The NAT64, where it only translation has the somewhat only have the NAT64 word, and the other keywords are convert between IPv6 and IPv4, so it would be translation. Then the last one is the dual stack, because of the same network segments. Dual stack, I remember that dual stack have the word segment in its description. So as you can see, let's try to check. So you can see, I've successfully matched the IPv4 and IPv6 terms to the descriptions. Then this is the 8th activity of the chapter 7, the practicing IPv6 representation. It is somewhat omitting zeros, or somewhat not excluding zeros. Then let's try to answer it. It is somewhat convert the IPv6 address into short, omit the leading zeros, and compressed form. So first we will gonna omit the leading zeros, then it would be just like this, 211, then it would be 0 because only 10, because you should omit the zeros. Then as you can see, we will gonna omit the zeros, so it would be DB88, then it should be 1111 and 0000. Oh no, it's 200. Then the compressed format would be 2001, then 0 dB, then 2 dots, then 200. Then as you can see, it's already checked. Then let's try to answer this. 2013, then it would be 0, then it would be 1 2 3, then it would be 1, I think 4 5 6 7 8 9 AB, then C D E F 0 1. And the compressed format would be 213, then this one, then 0, then 2 3 4 5 6 7 8 9 AB, then C D E F, then double colon, then 1. It would be correct, because you will only use the double colon in the last place if there's only 2 zeros, but you will only use the 2 colon in here. So then here, as you can see, it's all zeros, then so it will be 0 0 0 0 0 0 0, then 1 part 1. Then the answer would be 2 colons, then 1. As you can see, it's very easy. Then I'll try to answer it fast. 12 A B C D E F 0 1 2 3 4 5 6 7 8 9 10 A B B B. So it would be 12 colon A B C D, then colon again E F 0 1, then colon 6 7 8 colon 9 10, then colon again A colon B. Oh, it should be only for, oh why it is not, oh there's so many A, sorry for that. And there are so many. Oh, I didn't to include the 2 3 4 5, sorry for that guys. 6 7 8 9 10 B A B C D E F 0 1. Oh, it's 2012, sorry. Then A B 1 A 2 B 0 0, then 0 3, 4, 5, 6, 7, 8, 9, 1, again. A, B, E, then 0, then omit the 2 column, 2, 5, 6, 7, 8, then EB, 2B, then EF12, BFF3, 9125, then 1111, 101, EB, 2B, EF12, then BFF3, oh shit, sorry, A9125, then 111, so this should be for 1, then another 111, 101. Then another activity would be 1129. This would, I'll gonna cut this short because it is just very easy, guys, and you can get this right in a first try. Then 2929, then 1984, 2233, 44, 55, 66, 77, then 2 colon, then 101, then just right. Then I'll just gonna proceed to another activity because this activity is pretty easy and you can get it in just one try. Hello guys, this would be the 9th activity, I think, for the chapter 7, and as far as I know, chapter 7 has the most or have many activities. Then let's try to answer it. Drag the IPv6 address, type to the most appropriate description. Then first one, unique internet routable IPv6, dynamic or static. Then it would be global unicast because of this internet routable IPv6 address. It can't be link local because link local is different address from the global unicast. Then the FE80 point or the double colon 1 would be the link local. It is the address for the link local. Then 2001 colon db8 colon acad double colon 1/64 would be the global unicast. As you can see, the difference of the link local and the global unicast address. Then typical IPv6 prefix used to indicate the network portion of the address. As you can see here in the third question or third description, 2001 colon db8 colon acad double colon 164, the prefix of it is 64 for IPv6, so we will drag the 64 in here. Then used to communicate with other devices on the same IPv6 subnet. The IPv6 subnet would be the FE80, so it would be a link local. And let's check. As you can see, it is correct, and that's all. And this is not an activity, but it is a configuration about the global unicast address, or somewhat the serial and gigabit ethernets. Then let's try. The first one is to configure and activate the following interface. Then it would be interface gigabit ethernet 00, then IPv6 address 201 db8 acad 1 and 64. Then nope, did not shut down command. Then another one would be exit. Interface gigabit. For me, I would exit in that particular sentence, but in this command it's not, so let's still continue. Then IPv6 address is 211, then db8 and acad 64. shutdown command, then let's go for interface serial 0, then IPv6 address would be 2001 APAD BB8 I think, then APAD, then 3 and 64, then the no shutdown command, and as you can see, I've successfully configured the R1 LAN interface. This is the somewhat, that's all. And in this configuration, we will somewhat just, it's not a configuration, but it is just somewhat a summary of how to show the commands. Then as you can see, enter the show command that will display the brief summary, then it will be show IPv6 interface brief if you want to. Then as you can see, the brief, that is the brief summary of the IPv6. Then 311, it is a dynamic, as you can see. Then the IPv6 display routing table, show IPv6 route for the routing table, and that is the routing table of the IPv6. L is local, then C is connected, so you can see connected local, connected local, connected local. Then we will gonna ping. Ping is used for the connectivity of the device. And as you can see, success rate is 100% and it echoes. And as you can see, we've verified the IPv6 configurations.